So pulsars and magnetars. These are two weird kinds of stars. To me, they kind of sound like Pokemon. Like, oh, pulsar, I choose you. Okay, magnetar, get back in my Pokeball. Right? Anyway, what are they? Let's take them one by one. Let's talk pulsars first. Okay, let's talk pulsars first. What is a pulsar? Well, based on the name pulsar, it's named after something that happens to the brightness, okay? It's named after something that happens to the brightness. The brightness pulses, okay? The brightness pulses. Let me show you what I mean. Here is a set of pictures of a pulsar, okay? It's not just one photograph, it's several photographs taken over time. So here's one photograph, here's another photograph. Here's one photograph, here's another photograph. Photograph, 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 photograph. And so what's happening to the brightness of this this pulsar, it's turning on and then dim. Bright, dim, bright, dim, bright, dim. And one thing that's kind of cool about it is that it always flashes in a regular amount of time. It is very much like a rave light. It's like a strobe star, like a strobe light star. It turns on and off, and it's always the same amount of time for every flash. And they're not all the same speed. The slowest pulsars flash once every 8 seconds. But the fastest ones flash close to 1,000 times every second, which means they're flashing so fast that you wouldn't even notice that it was flashing with your eyes. You'd have to slow down a video to notice it was flashing. But yeah, they flash, they blink on and off. Now, why am I talking about them right now? Because it turns out pulsars are just neutron stars in a special situation. Pulsars, just neutron stars in a special situation. Well, let me get my picture back. Actually, I think there's a picture from your book that draws it better. Here's that same picture I just drew. You got your neutron star, you got your magnetic field, and you got your jets, right? Here's the thing. The jets come out of the magnetic poles of the star. But those are not necessarily the true poles of the star. Let's say that this neutron star was rotating around this line right here. They called that the rotation axis. Let's say that this was the true north and south pole of that star. Then, if it rotates like this, let me see. Okay, here we go. Let me, ignore all of this stuff. Physical demonstration. What you guys can't see is I'm dodging tons and tons of toys all over the toys and video games all over the ground. So I got to be careful here. Okay, so let's say I'm the neutron star, okay, and I'm spinning like this. But my jets, my magnetic poles were like this, just like in the picture. See how I'm kind of lined up with that picture? If I rotate like this, that's going to make it look like it's flashing. Because check it out. If I do this, if I have these two beams like this, when is it going to look like it's flashing? Why is this going to make it look like it's flashing? What's going on there? Whoop! Green screen. Redeploy green screen. Yeah, when the beam points in your direction, it flashes. That's very much like something that you probably have heard of. There's a man-made object that's exactly like that. What is it like? It's a lighthouse. It's a lighthouse. A lighthouse has two beams of lights coming out of it, and as it rotates, it will look like it flashes when the beam points in your direction. Neutron stars, if they have a crooked magnetic field, when they spin, they act like a natural lighthouse. So that's what a pulsar is. A pulsar is a neutron star with a crooked magnetic field spinning like a lighthouse. Okay? A pulsar is a neutron star with a crooked magnetic field spinning like a lighthouse. There's one last thing I want to say about pulsars before we move on to magnetars. What does this tell us about how fast neutron stars spin? Are neutron stars spinning quickly or slowly based on what we've said about pulsars? Really fast. Like ridiculously fast. Remember, these things flash up to 1,000 times a second, and at their slowest, they're flashing every 8 seconds. So that means that neutron stars rotate between once every 8 seconds and close to 1,000 times a second, which is crazy because remember, they're the size of New York City. It's something the size of New York City spinning up to 1,000 times a second. If the Earth spun 1,000 times a second, it would be ripped apart. We would be flung into space, and Earth would rip itself apart. Why does the neutron star not rip itself apart? Why does this extremely ridiculously fast rotation not rip the neutron star apart? What helps it hold together? It's the high gravity. Yes, it's the high gravity. Last thing I got to say about that rotation. Why do neutron stars rotate so quickly? Well, remember, what kind of star produces a neutron star? What kind of star? It's a high mass star, right? It's a high mass star. So, and that high mass star, if you watch the last couple of videos, you'll know that that high mass star was a supergiant close to its width is close to the size of the orbit of Jupiter before it blew up. So that means a slowly rotating giant star, as it crushed down, what naturally happens to the rotation of an object when it shrinks? Think of figure skaters. Think of figure skaters. When figure skaters bring their arms in and make themselves smaller while they're spinning, what happens to their rotation? Yeah, it gets faster. This is the exact same thing. So the reason that neutron stars rotate so ridiculously fast is because they originally were a giant star rotating at a more normal speed, but because they had to shrink down to the size of New York City, their rotation automatically sped up. Yes, yes, yes.